We think we've got a pretty good handle on how AI works. You give it a prompt, it spits out an answer. Seems pretty straightforward, right? But what if I told you that under the surface of that confident-sounding response, there's a process so fragile, so delicate, that one single tiny word could send it down a completely different path into a whole other reality? That's what we're digging into today. All right, let's start with something that makes total sense. You ask the AI about the British head of state, but you change the year in the prompt. First 2021, then 2024. And like clockwork, the AI updates its answer from Queen Elizabeth to King Charles. It's logical, it's consistent. This is exactly what we expect an AI to do. But here's the thing. The difference between 2021 and 2024 is, well, it's pretty obvious. It's a major fact. What happens when the change isn't something so big? What if the pivot point is so tiny you wouldn't even notice it, but the final answer shifts just as dramatically? This is the exact mystery that a team of researchers from Harvard and the University of Chicago decided to tackle. They wanted to peek behind the curtain and understand the AI's reasoning process. And what they found is, well, it's a fascinating and, I gotta say, a slightly unsettling discovery about how these models really think. So they came up with this really cool idea they call the forking tokens hypothesis. And it's an amazing way to picture what's happening. Think of it like one of those choose-your-own-adventure books, but the story is literally being written on the fly, one word at a time. So here's the core of it. As an AI generates a response, it's constantly choosing the next word from a list of possibilities. Most of these choices are pretty minor, but every so often, it hits one of these forking tokens. These are the critical pivot points, and choosing one word over another, even if they both seem just as likely, can send the AI's logic careening down a completely different path to a totally different conclusion. And this really breaks it down perfectly. Think about it like a GPS on a super long road trip. Most of the turns are just small adjustments, right? But a forking token, that's like the very first turn you take leaving your driveway. If the GPS says turn left instead of turn right by mistake, your entire 10-hour journey is completely different from that one single initial decision. That's what's happening inside the AI. Okay, so it's a great theory, right? But how in the world do you actually prove it? It's not like you can just ask the AI, hey, why'd you change your mind back there? So the researchers had to get clever. They developed a pretty brilliant method to map out all these potential forking paths and actually catch the AI in the act of changing its mind. What they did was incredibly meticulous. First, they'd get a standard answer. Then they would go back through that answer word by word, and at every single step, they'd force the AI to explore all the what-if scenarios. They'd say, okay, instead of that word, what if you'd picked one of these other likely words? And by running thousands of these alternate realities, they could pinpoint the exact moment, the single word that sent the AI down a completely different rabbit hole. And what they found, well, it was way more chaotic than they ever expected. It wasn't just a few forks in the road here and there. They uncovered this phenomenon they call a certainty collapse, where an AI's confidence can just completely and suddenly flip on a dime. Let's look at a real-world example from their study. The AI gets a trivia question. Name the American actress born on June 19, 1972, who was in the movie The In-Laws. Now, the correct answer is Robin Tunney. And as you can see, the model starts out on the right track, beginning its reasoning process. And if you could look inside its head at this point, you'd see this. Its internal confidence is super high, about 80% sure that the answer is Robin Tunney. Everything seems to be going great, but then it generates one single wrong fact. It basically hallucinates, confidently stating something that just isn't true. This right here is the forking token. In the middle of its reasoning, the AI just hallucinates. It confidently invents a false fact, saying the actress is Mia Sara, who, by the way, was born in a completely different year. And in that one instant, everything changes. Now look at what happens to its confidence. It doesn't just dip, it completely collapses and flips on its head. That 80% confidence in the right answer, it plummets to just 5%. And its confidence in the wrong answer, Mia Sara, skyrockets to 95%. It is now almost absolutely certain of the wrong answer, all because of one single hallucinated misstep. And here's the really wild part. It wasn't always some big, glaring factual error that caused these massive shifts. The researchers found that sometimes the most influential, reality-bending tokens were the most boring things you could imagine. A parenthesis, the word that instead of who. Get this, even a simple space character could cause the AI to completely alter its path. So the researchers put a hard number on this, and it's kind of mind-blowing. For a tough set of trivia questions, they found that an AI's initial line of reasoning had only a 13% chance of making it all the way to the end without a forking token knocking it off course. To put it another way, there's an 87% chance it's going to veer off into a different reality somewhere along the way. So, okay, this is clearly more than just a weird little technical quirk, right? This discovery of forking paths has massive real-world implications for how we build, how we trust, and how we interact with these incredibly powerful tools. The big takeaway here is that an AI's final answer, no matter how confident it seems, it just doesn't tell you the whole story. Its path to get there is unbelievably fragile. A single wrong turn could flip a response from safe to dangerous. And that final confidence score, it's totally misleading. It could be 99% sure of an answer it was 80% sure was wrong just a few seconds earlier. It shows that these models, they're improvising, not planning. And this slide just nails the fundamental difference between us and them. See, if I start telling a story about a hotel, but I accidentally say hole, I'm going to catch myself, laugh, and correct it, because I have an intention for the story. The LLM has no such intent. If it says hole, it doesn't back up, it just commits and continues on with a story that's now entirely about a hole. That mistake becomes the new plot. And that leaves us with this really provocative question, doesn't it? The answers we get from AI, the ones that feel so solid, so authoritative, they might be way more fragile, more accidental than we ever realized. It makes you wonder, the reality it's presenting to you right now, how many other realities could it have chosen just one word ago?